Okay, so I found a couple more trig question types. So in this one, oh gosh, I can't see the paper. So in this one, they're giving us cosine over sine plus sine over cosine, and they're wanting us to simplify that down to one of these answer options. All right. So the thing to notice here is that in the answer options, there weren't two separate fractions, so we actually need to put these fractions together somehow. All right, to do that, I'm going to give these a common denominator. So I'm going to multiply top and bottom here by cosine. All right, that way I get a sine and cosine on the bottom. And this one, I'm going to multiply top and bottom by the sine. Okay. So if I do that, I'm going to get cosine times cosine, which is cosine squared. All right. And I guess I'll just go ahead and put it sine, cosine, cosine, sine, whatever, multiplied by. And on this one, it would be sine squared. And I get the same thing there, cosine times sine. But now that they have the same denominators, I can actually put them together. All right. So it's going to be sine, cosine. And then up top, we get cosine squared plus sine squared, or sine squared plus cosine squared. And if you remember from that last video, this is a Pythagorean identity. It's the most famous one. So if you ever see sine squared plus cosine squared, you can replace it with a 1. So what this is 1 over sine times cosine. And I believe that was the answer. 1 over sine times cosine. That's it. Okay. Which of the following forms an identity with tangent of x over secant of x? So this one is going to require a little bit more knowledge. All right, so tangent over secant. So I didn't mention this. I mentioned that tangent was equal to opposite over adjacent, but tangent is also equal to sine over cosine. All right. Now, if you had, for I guess a short proof here, but if this is sine, opposite over hypotenuse, and you stack that on top of adjacent over hypotenuse, well, what happens if you actually do the keep, change, flip, where you divide the two fractions, what you end up with is opposite over adjacent, which is the definition for tangent. So that's why tangent is equal to sine over cosine. So what we're going to do here is we're going to rewrite these in terms of sine and cosine is what we do. So tangent, that's equal to, oh, not opposite, that's equal to sine over cosine, and then divided by secant. So I mentioned that secant was hypotenuse over adjacent, but it's also the reciprocal of cosine. So you can also define secant to just be 1 over cosine. It's the reciprocal of cosine. And same thing goes for like cotangent, tangent. Like tangent would be 1 over cotangent, or you could say cotangent is equal to 1 over tangent. These are all equivalent statements. Like I could say that sine is equal to 1 over cosecant, or I could say cosecant is equal to 1 over sine. All right, you're able to flip them, and that's like the definition of a reciprocal. So secant, that's 1 over cosine. All right, so what I'm going to do here is keep, change, flip. So I'm going to keep it as sine over cosine, change it to multiplication, and I'll flip it, cosine over 1. Then what happens here is your cosines just cancel each other out, and you're left with sine over 1. So the answer would be A, sine of x. Cool. All right, so if you're lucky enough to find something like this on the ACT, you could simply throw it into your calculator, I guess. All right, on. that. Remember, mode, make sure you're in degree mode though. All right. So if they're giving you these angles right here in degrees, that's the mode you're going to be in. The other way would be if they ask something like this, sine of pi over 3, something like that. This is in radians, so your calculator would have to be in radian mode. But most of the time, everything's done in degrees, most of the time. But your calculator's not in degree mode most of the time. So you could simply enter it in. Alpha y equals to make that. Sine of 60. Cosine 30. And tangent of 45. There we go. It does all the work for you. So this gives you 0.75, which is 3/4. Awesome. So, I don't know where my pause button went. Find the value of x. Okay, yeah, this would be a good one. We can do this real quick. All right, let me draw this. So I don't think you actually have to have trigonometry for this. This was sort of a topic that they usually talk about in geometry. This is a special triangle. This is a 30, 60, 90 triangle. But most of us don't remember the trick for these. So what you would want to do is you would want to relate this angle to the sides that you know. So x would be your adjacent side, and 6 would be the hypotenuse. So adjacent and hypotenuse, that's going to be cosine. Okay. So what the equation we're going to write is cosine of 60 is equal to adjacent over hypotenuse. Okay. You would multiply by 6. So your answer is going to be 6 cosine of 60. That might be how they have it on the test. But if you punch that in, 6 times the cosine of 60, it's going to give you 3. Yep. 3. Yeah, it is a handy trick to know. Anytime you have a 30, 60, 90 triangle, the way it works is the short side is always half of the hypotenuse, right? And then the medium leg, like you're not, how are you going to remember all this junk? But the medium leg is actually always square root of 3 times this leg. So it would be 3 root 3. But you could get that using the Pythagorean identity, Pythagorean theorem if you had to. All right. If I can find where my screen went, I'll call it a day. And we'll end there if I can find it. I see it.